So this audio PowerPoint is on classical conditioning, which is part of Chapter 6. So first let's define what learning is overall. Learning is a relatively permanent change in behavior or knowledge that results from an experience. Learning involves acquiring knowledge and skills, again, through experience. So now let's look specifically at learning through classical conditioning. Classical conditioning is a process by which we learn to associate, and pay attention to that word, associate, stimuli, and consequently to anticipate events. So essentially we learn to associate two things, two stimuli together, and then we're able to anticipate events. You might have read in your textbook that the first scientist to discover classical conditioning was Ivan Pavlov, and so I included a brief video of his work below. I think that'll give you more information on not only him, but the process of classical conditioning. So be sure and watch that. So classical conditioning includes an unconditioned stimulus, an unconditioned response, a conditioned stimulus, and a conditioned response. So let's go over his video again and kind of look at what each one of those look like in his experiment. The unconditioned stimulus was the dog food. Dog food naturally makes a dog to respond with salivation, the unconditioned response. Pavlov began to pair the dog food with the sound of a metronome, and he learned that eventually, because they were paired together, they were associated, that the metronome began to also produce salivation. So the metronome begins to cause salivation even in the absence of the dog food. So the dog learned that the metronome and the dog food were associated together. Let's look at another example, maybe a more real-world example. So the unconditioned stimulus you see here is a picture of an IV. We know that the chemotherapy often causes nausea and vomiting and people to develop a food aversion. So that's the chemotherapy is the unconditioned stimulus. Naturally causes the unconditioned response of nausea and vomiting. However, the patient will often begin to associate the administration of the chemotherapy with the hospital, maybe the smells, the tastes that they have within the hospital, the sight of the infusion or the nurse or the doctor. They may begin to associate that with the chemotherapy, and therefore the conditioned stimulus of the hospital and the smells and tastes begin to create the nausea and vomiting that the actual chemo creates. So there's an association again between the chemo being administered and the hospital, to the point that even just the hospital creates that nausea and vomiting. So let's look at higher order conditioning, which is also called second order conditioning. So you have the electric can opener, which is the conditioned stimulus that has become associated with food. As we saw in Pavlov's example, food automatically creates salivation. So this is pretty much the same as Pavlov's example, where the noise of the electric can opener, the cat then begins to associate that also with salivation. So let's say there's the noise of the electric can opener, which is now causing salivation. Begins to be associated with the squeaky cabinet door. So now we've got two things that are creating salivation. So the squeaky cabinet door and the electric can opener will create salivation. And so now you can even take the electric can opener out of the equation, and the squeaky cabinet door is now going to cause salivation. So that, again, that's called higher order or second order conditioning, because there's a second stimulus involved, which eventually becomes a creator of salivation. A few other things to know about classical conditioning. Acquisition is when an organism learns to connect a neutral stimulus and an unconditioned stimulus. During acquisition, the neutral stimulus begins to elicit the conditioned response, and eventually the neutral stimulus becomes a conditioned stimulus capable of eliciting the conditioned response by itself. So let's look at an example of that. So we know that Pavlov's dog begins to connect the metronome to the dog food. We know that the metronome starts producing salivation. Again, as I just said, the metronome then begins to elicit the salivation. Once this connection has been made, the metronome becomes a conditioned stimulus. Therefore, it begins to elicit salivation. And that's what we've already talked about. We know that the metronome and the dog food just become associated together. And it becomes such a strong association that the metronome itself elicits salivation. So again, before conditioning, the unconditioned stimulus would be the food, or I believe it's a turkey in this picture, which produces salivation. The neutral stimulus, the bell, is then paired with the food, and there's no response initially. A dog is not going to salivate to the sound of a bell. But then you pair the bell with the turkey, and they'll salivate, and then after conditioning, they eventually salivate to just the bell. So that's kind of just another example of what we've talked about with Pavlov and the chemotherapy. Extinction means there is a gradual weakening and disappearance of the conditioned response. So once the metronome is no longer presented with the dog food, the association between it and the conditioned response eventually becomes extinct. In other words, it doesn't last forever. Once they're no longer presented together, it becomes extinct. In other words, the metronome no longer causes the dog to salivate. However, spontaneous recovery can occur. After a period of time, when the metronome is reintroduced with the dog food, the dog will quickly remember that association between the two and may once again salivate in response to the metronome. So once it's already been associated, it may become extinct, the association may go away, but if it's introduced again, it's going to spontaneously recover. It's going to quickly recover. Stimulus discrimination. An organism learns to respond differently to various stimuli that are similar, which is called stimulus discrimination. The organism demonstrates the conditioned response only to the conditioned stimulus. Let's look at an example of Pavlov's dog. Pavlov's dog is able to distinguish between the sound of a metronome and the sound of a buzzer. Therefore, he does not salivate in response to the buzzer. So he's able to tell the difference between the sound of the metronome and the sound of a buzzer. Therefore, you can't pair those together and him salivate in response to the buzzer. However, stimulus generalization can also occur, and that's the opposite of stimulus discrimination, and occurs when an organism demonstrates the conditioned response to stimuli that are similar. So now Pavlov's dog is unable to distinguish the difference between the metronome and perhaps a clock ticking. So he begins salivating in the response to the clock also. And this is kind of what we were talking about with the higher order conditioning, how two things are now paired together. And he begins to salivate in response to both because they're so similar. So here's just a little diagram of generalization and discrimination. Again, stimulus generalization involves giving a conditioned response to stimuli that are similar to the conditioned stimulus. So the clock ticking and the metronome, they're very similar, so the dog begins to respond to both. On the other hand, again, stimulus discrimination involves responding to one stimulus, but not to stimuli that are similar. So the dog is able to tell the difference between the metronome and the buzzer, so doesn't respond to the buzzer. And I'm not able to move to the next slide, but that was the end of the presentation anyway. So thank you, and let me know if you have any questions.